Hello and welcome to another one of D's ADD videos. Today we're going to be talking about subspaces. What is a subspace? Well, subspace is basically a subdivision of either R2 or R3 in which there's a certain pattern to that subspace. And for it to be a valid subspace, it must be closed under addition and closed under multiplication, scalar multiplication. What does that mean? Well, what that means is if you were to add or do the multiplication, the pattern that the initial vectors possess must be preserved in your final answer. What do I mean by that? Well, let's look at R2. Let's look at the subspace of all the vectors that contain the pattern of A, 0. Now, for addition, the question would be posed as follows. If I take A, 0 and some other vector B, 0 and I add them, do I get the same pattern? Oops. Come on, eraser. There you are. Of some number, 0. Do I get that same pattern? That's the question. Well, sure enough, you should be able to see that when I add my x terms here, I get a plus b, and 0 plus 0 is that. So, true enough, those two equal. Then let's do a scalar multiplication one. Here we're going to say k times the entire vector. Is it equal to plugging in a ka everywhere you see the vector or the variable a? So if I multiply through, I get k times 0, which does indeed give me ka, 0, because 0 times anything is itself. So this is therefore both closed under addition and all this would need to be stated, and closed under multiplication. Therefore, it is a valid subspace because we were able to preserve the pattern. Alright? I'm going to give you one that doesn't work out too nicely. Let's look at, again, R2, A, 1. Alright? So if we're looking at A, 1, the question would be posed like this. A, 1, some other vector B, 1, and the question is saying that A plus B, the first term, and then is the second spot 1. Well, right away you can see that whenever I add the 1 and 1, I'm not going to get the desired pattern that should show up for every vector in this subspace of R2. Right? Because of this 2 right here not being a 1, then it's not closed under addition. So you can stop right there. Oops, not closed. This is what happens when you record late night. Under addition. And then just for completeness, let me just go ahead and show you the multiplication. But right away you could have said at this point that it's not a valid subspace because one or the other fails, it's not a subspace. So here, if I look at the pattern of a comma 1, the question would be, this is testing multiplication here, this one was addition, oops, sorry about that. To my darkness level there. Does it equal the same thing as plugging in a K, A everywhere you see an A? So right away you should be able to notice that when I distribute that K, A through, this is what I get, and that question that I previously asked is not coming to pass, right? Why? Because K does not equal 1. So not closed under multiplication, therefore not a subspace. Either way, not a subspace. Alright, so that should give you enough to work these subspace problems out. There might be an R31 given. It doesn't mean anything changes. Or your A might not be in the first position, it might be in the second position. Whatever the case, just practice, 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 and you should understand these. I hope this has clarified any doubts that you might have. Please check out further example videos to answer any further questions. Thank you and have a good day.